In this video, we are going to analyze a 2D flat plate. Already we have done in the previous video. We are going to continue in this video. Already we have done different types of different number of divisions for the flat plate during meshing process. So we will give edit on the meshing. We will just change the number of divisions. In first case we have given 100. So now we are going to give 400. So this is the previous mesh what we have done before. So we are going to change this mesh to make more fine. Instead of giving 100, change it to 400. After changing to 400, give generate. If you give generate, you can able to see the structural mesh which is more fine when compared to the previous one. I click generate and then go to edge meshing sizing 2. In x direction, change it instead of 50 to 200, then give generate. After giving generate, you can able to see the meshing which is more fine when compared to the previous video. So if we able to zoom in, you can able to see the mesh type. You can able to see over here. From this you can able to understand the different types of meshing. After giving the meshing number of divisions, click update. After clicking update, go to setup edit. This is the previous result what I got in the previous video. I am continue this video, cancel, and then you can able to check the residuals what you have got in the previous sections. So here we are going to see the result for this number of divisions. First we gave different types of divisions, and then now in the second case we are just changing the number of divisions in x and y directions. Make sure that everything is okay. Then give display. You can able to see the figure. So it look like a 2D figure. After giving general, you just check it again, report quality, and then display. Click all the parts. I forgot to give all the parts, that's why it's not visible. After clicking all the parts, you can able to see the picture. Green like structure is a 2D flat plate with of same dimension 100 cross 200 mm in x and y directions respectively. So again we are giving the run calculation. So first we have to initialize it because of the previous results already we have got. So we should initialize this. So the result will come from first onwards. The hybrid initialization is done. Then go to run calculation. After going to run calculation, we gave 100 the previous value. Again you give 100 in this case as well. So it is showing solution state will now also be updated. So you click on OK. Click OK. The calculation has been completed. It's a very quick process. See, the number of iteration is 7. In the previous case, it has been done in 8 iterations, but in this case it has been 7 iterations. So the same graph you can able to see over here. Around 373 is a peak temperature at 0.01 position in meters. So you can able to see it's like a same when compared to the previous one. There is no that much difference. So you can able to see the graph static temperature versus position. So from this we can able to conclude that after changing the number of divisions also the results looking similar. That's the main important thing. Go to graphics and then click contours. So to see the contour, that contour, give all the bodies and then give save and display. After giving all those things, change it to temperature. After changing to temperature, you can able to see the figure of the scaled residual what you have got. This is the final result what you have got in the temperature versus static temperature. You can able to see the figure what you have got. This is the final result. This is the result which is similar to the previous case. So from this we can able to conclude that changing the mesh is number of divisions gives almost a same similar type of results.